We're thrilled to introduce our new climate data visualization application that offers an immersive and interactive experience for any location on the planet. The app is designed to help users gain a better understanding of the climate conditions of presented locations. Our team has made the app highly customizable, providing developers at SINTEF the ability to modify and adjust the app's features to suit their needs. Our app leverages NetCDF files, a format for scientific data, which is used to store climate data at SINTEF. The app offers two unique experiences: a miniature model of the real-world location and an immersive model where you can fly around a life-size version of the environment. This allows you to easily visualize the complex relationships between different climate data points and offers an enjoyable and interactive experience for all users. We've utilized Unity technology to create customizable template scenes that can be easily modified with different datasets and loaded onto a VR headset without requiring any additional modifications. In the following demo, we will show how to make an application visualizing data for a section of Bergen city, with automatically generated wind speed and radiation visualization. First off, let's take a look at how a developer at SINTEF might create a VR application that visualizes the data. Upon opening the project in the Unity editor, the developer will be presented with a demo scene containing a miniature of Bergen. In the bottom toolbar, the project's assets can be found, which include the demo scenes of Bergen and two template scenes. The template scenes contain all information apart from the climate data, most importantly aesthetics surrounding the miniature map, in addition to more technical aspects of the application, such as the user interface or the player character. The template scenes are used when generating scenes at new geographical locations or when using different climate data. This makes it very easy for the developer to modify the appearance of new scenes. The climate data is generated through scanning any NetCDF files provided by the developer. The developer needs to specify what variable names contain the relevant data. When all is set, our editor plugin automatically handles binding variables to building positions, elevation data, climate data, and radiation. After the correct variables are set and we hit the Generate Scenes button, the template scenes and NetCDF data are seamlessly combined into two new scenes. By using this Scene Generator plugin, the developer can create real-time visualizations of any real-world location in only a few minutes. We can now build the scenes we created and experience this in virtual reality. Once loading is complete, the user finds themselves in a room containing a miniature version of the map, in addition to a tutorial panel. The user should intuitively start to browse through the tutorial slides to learn about the controls. We enabled a variety of locomotion options. Smooth, continuous locomotion makes for the most realistic experience, but can cause motion sickness for some. Teleportation solves this issue, but is a bit more difficult to position yourself with accurately. The miniature map is interactable and can be panned and scaled according to the user's wish. The gestures function the same as navigating a map on a smartphone, so they should be easy to learn. The user interface is used to alter the presentation of data on the map. The climate data has a time dimension, which can be inspected using the time slider or the play button. The data we've been provided with shows wind speeds in Bergen over time. Furthermore, we've added some quality of life options, such as changing the opacity or the height of the clouds, making it easier to see the radiation and buildings underneath. Similarly, radiation and buildings can be toggled off if only the clouds are of interest. We've now looked at the miniature version of the map. Let's see what it looks like if we were immersed inside the map. The point of the full-scale version is to give a more realistic perspective on the climate data and get a better sense of scale. This is where using VR really makes a difference. We can see that all the same data elements are still present, and all alterations to the presentation of data, that is, inspecting the time dimension of the clouds, changing its opacity or height, or toggling other data elements, can also be performed in the full-scale version. Locomotion is similar to before, including continuous locomotion and teleportation, only that now the user can freely move up and down as well. Whether you're a climate scientist, urban planner, or simply interested in exploring the world around you, our app is the perfect tool to help you visualize climate data like never before. That was all the functionality we would like to share with you. Thank you for your attention.